Children, now in this video we'll study the chemical reactions of haloalkanes and haloarenes. So basically the chemical reactions of haloalkanes and haloarenes are of three types. The first one is nucleophilic substitution, second is elimination, and the third one is reaction with metals. So in order to understand nucleophilic substitution reaction, first let me explain you what is nucleophilic substitution reaction. You can see this is carbon halogen bond. There is a partial positive as well as the partial negative charge on carbon and halogen respectively. The halogen atoms in haloalkanes are more electronegative than carbon atom attached to it. And this is the main reason they acquire partial positive charge and halogen acquire partial negative charge. This acquiring of charge, positive charge on carbon and negative charge on halogen, helps the attack of nucleophile. Nucleophiles or nucleophilic reagent. Nucleophiles or nucleophilic reagent are the reagents possessing a negative charge or a lone pair of electron. You can see a negative charge here. When a nucleophile stronger than halide approaches positively charged carbon atom of alkyl halide, the halogen atom with its bonding pair of electron is displaced and a new bond between carbon and the incoming nucleophile is formed. Hence, such type of reactions in which a stronger nucleophile displaces a weaker nucleophile, or you can say halogen or halide ion, is known as nucleophilic substitution reaction. And a group, atom or group, in this case halide, which leaves the bonding pair of electron is called as leaving group. Here I have represented it as Lg. Leaving group are maybe Cl, Br, I. Better the leaving group, more facile is the nucleophilic substitution reaction. Few nucleophiles I would like to give an example. Like we have OH minus, I minus, NH3, CN, NO2, HS, RCOO minus are few nucleophiles which are used as a nucleophilic reagent in nucleophilic substitution reaction of alkyl halides. While in my explanation, I said that CN is also one of the nucleophile. So you can see a resonance hybrid or resonating structure of cyanide ion. In this case, either the carbon or the nitrogen atom can act as an electron donor to the alkyl halide. Such nucleophiles which have more than one site through which the reaction can occur are called ambident nucleophile. So nucleophilic substitution is of two types, as you can see here, SN1 and SN2. SN1 means substitution nucleophilic unimolecular and SN2 substitution nucleophilic bimolecular. Here 2 and 1 represents bimolecular and unimolecular respectively. So now first we'll study SN2, that is substitution nucleophilic bimolecular reaction. So the reaction is between methyl chloride and hydroxide ion to give methanol and chloride ion. This follows second order kinetics. Second order kinetics means rate of reaction depends upon concentration of both the reactant. Means alkyl halide and nucleophile are taking part simultaneously in rate determining step of the reaction. मतलब इसमें सबस्ट्रेट और रिएक्टेंट दोनों की ही ज़रूरत पड़ती है. आपको इसमें दिख रहा है मैंने एक प्राइमरी एल्किल हैलाइड लिया है. प्राइमरी एल्किल हैलाइड इसीलिए क्योंकि हमें इस SN2 रिएक्शन में यहाँ ज़्यादा भीड़ भाड़ नहीं चाहिए. ये प्राइमरी में सबसे अच्छा होता है. नाउ भीड़ मीन्स hindrance. There should be no hindrance, no bulky group attached with the alkyl halide. So what happens? The incoming nucleophile approaches alkyl halide and starts interacting with, and the carbon halogen bond starts breaking and a new carbon OH bond starts forming. These two processes takes place simultaneously in a single step. You can see only one step is taking place and no intermediate is formed. Means SN2 reaction takes place in one step. These types of reactions usually give transition state. Transition state means reactant, means both the reactants are partially bonded to each other as shown here. This is your transition state. It is very interesting to note that in SN2 reaction, the attack of nucleophile, that is the OH ion which you can see, occurs from the back side. This attack takes place like this. And this tries to leave. So SN2 reactions are always accompanied by inversions. Inversion means, you can see, if you consider this as your hand and these are the spokes of the umbrella, you are holding your hand and the umbrella here. After the reaction gets completed, you will see this is representing your hand and this is representing the spokes of the umbrella. Clear? So the umbrella gets inverted in a similar way as an umbrella turns inside out in a strong wind. This type of inversion is also called as Walden inversion. Clear? Now next is SN1 reaction, that is substitution nucleophilic unimolecular reaction. Now see the reaction clearly. SN1 reactions are generally carried out in a polar protic solvent, PP, polar protic solvent, such as water, alcohol, acetic acid. Now in this you can see, as you remembered in SN2 reaction, I said भीड़ भाड़ कम है. यहाँ क्या है? भीड़ भाड़ ज़्यादा है, hindrance है. Now this carbon is sp3 hybridized, and this carbocation forms sp2, that is trigonal planar. Now let's go through the reaction fast. This reaction takes place in tertiary butyl bromide, means we are studying the reaction in tertiary butyl bromide, and OH minus ion, it gives tertiary butyl alcohol. SN1 reaction follows first order kinetics, means the rate of reaction depends upon only the concentration of the reactant, not it is independent, means not at all dependent on the concentration of OH minus ion, that is the nucleophile. So the first step, as I have written here, is a slow step. What happens in the first step? It is reversible. Hence, is the rate determining step of the reaction. You can clearly see in the first step, the carbon-chlorine bond breaks and a carbocation is formed. Or you can say carbon-halogen or carbon-bromine bond breaks and a carbocation is formed. In the second step, this carbocation is reactive, is highly reactive. In SN2, what we have seen? Transition state. It is unstable. Why unstable? Because if you recall, if you go back, if you see that the carbon was having 5 bond. Clear? So this carbocation is a reactive chemical species. It will immediately be attacked by the nucleophile, that is OH minus ion, to give a substitution product, and the name of this product is tertiary butyl alcohol. This step is fast, hence does not affect the rate of reaction. Now this was all about your SN1 and SN2 reaction and their mechanism. Now we'll study further the difference between the SN1 and SN2 reaction. Then I'll give you a short trick also after this explanation. The first one, SN1 is a two-step reaction. In SN1, a carbocation is formed. In SN2, it's a one-step reaction and an intermediate is formed. In SN1, you have seen Walden inversion, that is inversion takes place. While in SN2, only inversion takes place. Means in SN1, retention or inversion both will take place. While in SN2, you will find that inversion will take place. Now, the order of reactivity, rate of concentration of one rate depends on the concentration of one reactant in SN1, while in SN2, the rate depends on the concentration of both the reactants. Order of reactivity, the tertiary alkyl halide is more reactive in SN1, means it will react fast. Because greater the stability of carbocation, more easily and faster will be the rate of the reaction. Clear? While in SN2, the order of the reaction is fast and primary. Okay? Primary alkyl halide. Why primary alkyl halide? Because no bulky group available. So, methyl halide, or you can say primary, are more reactive because they have small hydrogen atom only at alpha carbon. Okay? In SN1, you need polar protic solvents like water, alcohol, acids, while in SN2, you need polar aprotic solvents like acetone, DMF and DMS. Clear? Now, DMF is dimethyl formamide, DMS is dimethyl sulfoxide. The short trick for this is SN1, if you remember, you will automatically be able to do SN2. SN1 means unimolecular 1 2 means two-step. 3 means tertiary carbocation is more reactive. So 1, 2, 3 gives you the trick to understand the concept or short trick. Clear? So one more thing, in SN1 you will get little bit racemization also with some sort of inversion. Clear? This was all about your SN1 and SN2 reaction. For further reactions and some optical activity, we'll go through the next video. I hope you have understood this video and you have liked the video. Thank you and have a nice day.